Hello, my name is Timo Kerola and I come from Vaisala, a Finnish-based company making different weather measurement equipment. As nations prepare to confront new operating environments with modernized technology, it's more important than ever to base decisions on accurate and reliable data. And this is where Vaisala comes in. Our company is divided into two main business areas. We have the weather and environment business area, which focuses on creating products that measure outdoor conditions such as temperature, humidity, air pollution, things that you might find outside. Then we have our industrial measurement business area, which focuses on different kinds of indoor reference grade measurements that are used, for example, by pharmaceutical industries. And I come from the weather and environment business area, and we will talk about our products shortly thereafter. But first, shortly about Vaisala and numbers. In 2020, we had net sales of about 380 million euros, and 14% of this was directed to R&D. So we are an R&D company by heart. We employ 1,900 employees worldwide in 25 offices in 16 countries. We have a very broad product offering with over 300 different product families, and with these products we serve customers in over 150 countries. And a nice detail also about our company and these modern times is that today we are operating 100% on renewable electricity. Okay, so going to the weather and environment business area where I work as well. So the weather and environment business area is a partner to customers whose primary interest is the safety of people, protection of property, and efficiency of operations through reliable measurements and decision-making support under any environmental conditions. So what this might mean to military customers is that regardless of the weather, you will be able to get your job done. And this is maintained by, for example, knowing what the weather is right now and also getting the measurements you need to forecast what the weather will be like in some time in the future. Going deeper into artillery customers, Vaisala has been at the forefront of developing the ballistic meteorology concept. Our first radiosonde was released in 1936, and this was also the world's first commercially available radiosonde. And as many of you already know, understanding the atmospheric conditions is key to improve ballistic accuracy. So in these pictures I have plotted a few things. So on the picture on the left-hand side, we can see the air density error, and this is the measured air density compared to the standard air density. And why is this important? It is because some firing tables, if they do not have any accurate weather observation or any weather observation at all, they rely on the so-called standard air density model from the standard atmospheric model. And this means that they are shooting based on the standard model and not the real live conditions. And if we measure the difference, we can see that in this particular sounding, we could see up to 12% deviation to the standard air model. And this means that you will have a significant deviation in the actual flight path of the projectile. So this is really important to take into account when you are planning your fires. Another example is wind speed, and this is more easy to understand. Everyone knows how wind affects projectiles. In this same sounding, we had wind speeds of over 40 meters per second at altitudes between 10 and 15 kilometers. So it is really vital to measure the atmospheric conditions accurately all the way to high altitudes when you are planning your fires. And our offering is fielded worldwide. We have many different kind of customers in very many different regions. The core product is the RS-41 radiosonde and the MW32 Marwin sounding system, which receives the radiosonde signal and converts that into meteorological messages, such as the NATO METCM message. The RS-41 SGM radiosonde is specifically designed for this application, and it has safety features such as radio silence and encrypted telemetry transmission to improve the safety of your guys on the ground. And with radiosondes, it's important that you can measure accurately from surface up to altitudes even of 30 kilometers. So this is the so-called best possible measurement for artillery operations. But this is not why we are here today. So Vaisala has a new product line that continuously measures the lower levels of the atmosphere and the winds of these lower levels. And to tell you more, my colleague Toni Sturdel will be happy to give you the brief.
Thank you. Hello, I'm Toni Sturdel, an application manager from Vaisala. We are going to take a look at wind lidars, which are pretty recent addition to Vaisala product offering. To begin, what does word lidar mean? LiDAR acronym comes from light detection and ranging. Doppler wind lidars are laser-based equipment. They are used for measurement of wind within planetary boundary layer. The measurement itself is continuous and provides results in real time. Typical output format of a wind lidar data is shown here. On vertical axis we have altitude, and on horizontal axis we have time. One column represents a wind profile, where direction is shown with a wind barb, and wind speed with different colors. Wind profiles are shown next to each other as a function of time. And from this time series, we easily see the changes in wind conditions over time. Let's have a look what is a wind lidar. Here we explain pulsed Doppler lidar technology. The same measurement principles apply to all our wind lidars presented today. First, we see here some particles like aerosols moving in the atmosphere. Laser pulses are sent to atmosphere with certain frequency. Laser pulses reach aerosol layer, and pulse energy is backscattered from aerosols. This weak signal is received by LiDAR. LiDAR processes the received signal and does that for all measurement distances at once. This movement of the aerosol has caused a shift in the received frequency, and that is called a Doppler shift. Radial wind is derived from Doppler information. Concurrently with wind, the wind lidar is also receiving backscattering information. Wind lidar technology used in our products has been standardized in July 2017 by ISO. This means there are common definitions and understanding of the Doppler lidar parameters, as well as principle of operation. This is a key to a broader adoption of this technology. Vaisala is today a world leader in wind remote sensing with lidar technology. One reason being that our products are very accurate. The superior performance has been proven by independent parties in several measurement campaigns and comparisons. Typical comparison is made against reference anemometers installed on a wind mast. And here is one of such masts shown in the photo. Reference material for lidar accuracy is available from Vaisala upon request. Next, we are going to have a look at our wind lidars, the WindCube product family. The first product presented here is the WindCube, which is a vertical wind profiler. This product would literally replace a 300-meter met mast with virtually up to 20 sonic anemometers at different heights, which can be set by the user. In other words, user can have horizontal wind measured on desired altitudes below 300 meters at their desired location. More than 1,000 WindCubes are currently in operation globally for a wide range of applications, from wind energy to climate studies and industrial risk management. I'd like to emphasize that the WindCube is well suited for quick and easy deployments in the field environment. It's as small as 50 by 50 by 50 centimeters in size and weigh less than 50 kilos. So this is a fully autonomous wind lidar system designed to operate unattended. Second product presented is longer range, three-dimensional scanning Doppler lidar, so-called WindCube Scan series. This product with its scanning head is able to measure winds for full hemisphere, but it can also measure the wind vertical profile up to the top of the atmospheric boundary layer, and sometimes even above that. We have few different models available with different operational range, starting from several kilometers. As the WindCube Scan series are also eye-safe and well suited for deployment in various environments. Third product here is a tripod-mounted WindCube, which is measuring the wind profile from 40 meters to 700 meters upfront with very high accuracy. It is rugged and lightweight LiDAR, and similarly quickly set up and operational as our other LiDARs. Product itself can be dismantled in 3 pieces, and each of them are able to be carried by one man. The main use of this series is to control wind turbine performance, and that's where the product name is coming from. The tripod is mounted on top of the wind turbine nacelle, and the wind cube is measuring the incoming free wind across the blades. This kind of use case demonstrates the wind cube resistance to harsh environmental conditions. But the same product has also demonstrated adding value while measuring longitudinal and transverse wind components for precision shooting exercise. The following video presents a scanning LiDAR making a wind profile measurement. We see the scanning head of a LiDAR turning and making short stops. At each stop, the LiDAR is performing one measurement, and at each stop, the LiDAR is using slightly different measurement angle. After measuring with 5 different angles, the cycle starts again from the beginning, keeping the LiDAR running continuously. One measurement takes 1 second, so the wind profile information is updated every second, although the wind profile is always derived using 5 latest measurements. On the display, we see 3 graphs after updating: horizontal as well as vertical wind speeds, and also wind direction, and all 3 are concurrently shown at different altitudes. On the right, we see the results, a time series of measured wind profiles as a graph. Then we will have a look how our technology could be utilized in the field environment. So far, over 1,500 wind cubes have been deployed in different parts of the world and for very different applications. They have proven their capability to operate in harshest environments, from winter coldness to tropical heat, and from desert dryness to ocean moisture. In these photographs here, some examples are illustrated to show typical operational environments. Due to the rugged design of wind cubes, they can be used almost anywhere. The main application in defense are shown here. Wind LiDARs can be used to monitor surrounding winds in case of an accident or other type of situation where there could be hazardous chemicals or radiation in atmosphere. Wind LiDAR provides real-time high-resolution wind mapping after deployment to the field. Monitoring prevailing winds is a key in forecasting the dispersion of hazardous clouds. Primarily, a scanning or vertical LiDAR would be the product for this kind of use case. Secondly, the missile or artillery test ranges are places where the local wind profile information is very important. This information could be provided by vertical LiDAR, nacelle LiDAR, or a scanning LiDAR. Thirdly, aircraft operations would benefit a lot to have wind monitoring available. Helicopter fields having real-time wind profile and possibly wind shear monitoring for runways. Depending on the application, we could use scanning or vertical LiDAR here. Vaisala has delivered wind LiDARs to several defense customers globally. As an example, US Army is utilizing wind profile information from wind LiDARs in their test range in White Sands. Another example of such customer is from Europe, and that is French Army. Final question today is that what is the real difference using radio sounding or wind LiDARs for wind profiling? Radio sounding has been widely used with artillery for decades. It is a trusted instrument and relevant part of operations. With sounding, you get very accurate pressure, humidity, temperature, as well as wind information to high altitudes. But the limitation is the amount of soundings completed within a day. Typically, the information is updated with a new sounding every second hour or so. On the other hand, a wind LiDAR can give continuous wind information. Although the measurement height is capped at boundary layer top, it's typically enough to cover the required altitudes. With a wind LiDAR, it is also possible to have wind information from wider area, measure a profile, or have LiDAR looking into certain direction. In case In case you will have questions about wind lidars or other Vaisala products in future, here are the contact information. Thank you for your interest.